Okay, so here we're gonna start a new section called the planar graphs. Now we're gonna figure out what is a planar graph, right? So just kind of introduce the concept here, right? So here we see a simple graph here, right? And as we can see here, right, 5 vertices. What is it? 1, 2, 3, 6 edges. So the idea here of a planar graph, so these planar graphs live in a plane, so just a two-dimensional space, okay? And within that two-dimensional space, I want to know if I can can you draw a graph so that no edges cross? As we can clearly see here, there's a lot of edges crossing. But is there some kind of configuration where we have the same number of vertices, same number of edges, but none of the edges are crossing? All right, and that is, in a sense, that is the definition, I should say, of a planar graph, right? So a planar graph can be drawn in a plane with no edges crossing. Okay. All right, now here the word can is doing a lot of work here, right? So I want to stress that it can be, not that when we're presented it might not look planar. Okay, but it can be. There is a way for us to do that. All right, so let's take a look here. Go back to this one here. All right, so here again does not look planar, but again, can it be drawn in a plane? So what if I move this here? All right. So now we see that we have a graph here that lives on a plane, right? And none of the edges are crossing, right? So in fact, this graph is planar. All right, it can be drawn in such a manner. Again, right? Existence, right? This graph exists, right? It may not always look that way, but it does exist. All right, now when a graph is in planar form, we can, it kind of cuts up the plane into what we're going to call faces. All right, so here, let me go back to the notes here. So that representation here looks something like this. Okay, so it looked like this, all right? And you can think of kind of the space that you see in front of you there as the plane, right? And it cuts up the plane, and how it cuts it up, we can break down the different spaces as what we call faces, right? So here we could say, all right, this is a face, this is a face, but also out here, this whole other space out here is a face as well. All right. Now here, I just want to make sure that this only makes sense when it is a planar drawing, right? When it is not planar, then this concept of a face doesn't really hold. Okay. All right. So here, let's take a look here. All right. Here, draw two different. So now let's take a look here at, there's sometimes more than one way to draw this planar graph. So for example, let's say given a graph like this, we have 4 vertices, 6 edges. All right, so this is a complete graph. We see each vertex is going out to all the other vertices. All right, now here it's not planar, but I could draw it in such a way where we had, all right, what if I drew it like this? Right, or drew it like this. Okay, now in which case you see, right, the first one I drew there, it's not planar, but again, it's not drawn in a planar form. But again, that does not mean that it is not planar. As we could see here, there are two different versions of the planar graph. All right, so here let's look at the details of these graphs. So in each case, our vertices, E, is 4, right? Our edges here, E is 6. All right, now let's take a look at our faces. Now, again, it does not make sense in this form here, all right? Because even if we do it in another configuration, another form of faces might show up. So when we think of cutting up the plane, we think of it in terms of the planar graph, right? So here we could say there's one face here, two face here, 3, and then outside here, there is 4. Okay? All right. Here, so in this case, faces equals to 4. All right, and then here we see we have 1, 2, 3. And then the outer unbounded face as well. All right, so we can see here in both cases the faces are equal to 4. Okay. All right. So what we're gonna focus on here in our planar graphs is we want to establish a relationship or some pattern developing here between the vertices, the edges, and the faces in our planar graphs. All right, and again, things to emphasize here. All right, planar means that it can be drawn. Right, not that necessarily we're presented a graph, and if the edge is crossing, we can automatically cancel out, say, oh, it's not planar. Okay, the idea here is, well, for more complex looking graphs, how can I determine whether it is indeed a planar graph or not? Okay, because here when we have these number of vertices, that is fine, but if something more complex, I like a more streamlined approach to determining whether it is in fact planar or not than by just trying to rearrange all the vertices and edges.